All right, so we got into parabolas, and we started learning about the shifting of parabolas, how compared to that parent function x squared. What you're going to do today is really what that lesson 29 set us up for, which was using the definition of a parabola to write the equation of a parabola. And we're going to use what's called a focus and a directrix to do that. Now, this vocabulary is going to be brand new to you. You've probably never heard the term focus or directrix before, so just take a second and read what you have there. I don't want to bore you with it, but it is important, so we do have to kind of review this before we move along. The definition of a parabola is the set of all points equidistant from two things: a point and a line. The point is called the focus, the line is called the directrix. All right, and really, to understand this vocabulary, you really kind of you have to look at this picture in order to understand it. So what we have is, everyone knows what a parabola looks like, okay? And that's what we have here in blue. And the focus is right here on this particular diagram. The focus is right here. Now the focus is a point that's inside the parabola. So if the parabola is up, the focus is going to be inside the parabola. If the parabola opens down, the focus is going to be still inside the parabola, so it'll be below it actually. And the directrix is a line below the parabola, or if it's an upside down parabola, then the directrix will be above the parabola. And the directrix, it'll be outside the parabola. It's all based on the axis of symmetry. I know this is kind of weird. It's going to take a little time to understand, but once you get it, it's very, very easy, very basic. The axis of symmetry, you've probably heard that before. The axis of symmetry is the line of symmetry for the parabola. So if the parabola opens like this, the line of symmetry is right down the middle. The focus will always be right on the axis of symmetry inside the parabola, and the directrix will be perpendicular to the axis of symmetry. As you can see, our axis of symmetry is coming straight down here, straight down the middle of our parabola. Our focus is on the axis of symmetry, and the directrix is perpendicular to the axis of symmetry. Now, why do we have this focus and directrix? What are they for? Well, it turns out that if we have those correct points, the correct focus and the correct directrix, any point that you pick on the parabola, so like they picked one right here. See this point xy? And it could be any point. This point right here will be the same distance to the focus as it will be to the directrix. So if I measure the distance from this point to the focus, it will be the same as if I measure the distance from this point to the directrix. And you can kind of see that on your paper. See these little hash marks here? If you remember from geometry, that means congruent. That means the distance is equal, right? So this distance is equal to this distance. The distance from the focus to the distance from the focus to the vertex of the parabola, the distance right there is equal to the distance from the vertex to the directrix right here. So here to here is the same as here to here. So again, between the focus and the vertex, and between the vertex and the directrix, those are equal distances. So we can kind of put a little hash mark there. Equal distances. Those particular distances are extremely important to come up with the equation of the parabola. All right, and we are going to label it with a special letter that's going to represent the distance. We call that distance P. We call it P. So I'm going to label P on the diagram, and I'm going to have you do that now. Label P. So the P is the distance from the focus to the directrix. So just kind of do a little curly thing here and call it P. And then another one right here and call that P. P is the distance from the vertex to the focus and from the vertex to the directrix. All right, same distance. Again, you could pick any point on the parabola. This is the definition of a parabola. You can pick any point. So I'll pick this point right here. If you draw the distance from that point to the focus, it will be the same as from that point straight down to the directrix. See that? That is congruent to that. I'll pick another one. Pick a point right here, just for example. The distance from that point is the same to the focus as it is to the directrix. You can kind of tell that they're the same. I'll put 3 hash marks there. Just kind of like in geometry when you say side equal to side, you put, you add a little hash mark each time. So, and you can do that for any point. This point right here, same distance to the focus as it is to the directrix. All right? Boom, 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 boom. All right? We could do that on and on. You could pick any point in the parabola. So that's the purpose of the focus and the directrix. We're going to learn in this lesson how to go from the focus and directrix to the equation and how to go from the equation to the focus and directrix. So that's what we're going to be doing here. So exercise 1 is just drawing a little bit here. My mouse is not working well. All right, there we go. So to show the definition of parabola, let's draw several pairs of congruent segments. So let's just start with the most obvious one. Here's a focus, here's a directrix. So the distance from here from here to here and here to here, there's our vertex. Distance is equal. All right, let's do another one. From here to here will be the same as here to here. Equal. From here to here will be the same as here to here. All right? From focus to here is the same as there to there. And if they are, it's a parabola, and if they aren't, it's not a parabola. All right? We could just keep doing that forever. There to there, 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 there to there. Okay? You go to the parabola and then to the directrix. To the parabola, to a point, then to the directrix. From the focus to the parabola, from the parabola to the directrix. From the focus to the parabola down to the directrix. All right? And you just keep making congruent segments. All right. So in exercise 2, draw each parabola with the given focus and directrix. So we got to obviously the vertex would be in between the focus and directrix. So this is a focus, this is a directrix. We're going to go right in between. That's the vertex of my parabola. And then you just kind of make your parabola to be to where we pick a point that would be the same distance to the focus as it is to the directrix. Pick another point that looks like it might be about the same distance to the focus of the directrix. Pick another point that might be the same distance to the focus. We're just estimating now. All right, so here's our parabola. You got to try and pick points that are the same distance to the focus and the directrix. So obviously one right in the middle there, and then how about like that one, and then like there, and then there. All right, and then here maybe, and then here. We're just kind of estimating. This one's turned on its side. We're not really going to deal with any of those. And then right in the middle, and then this one's going down, so how about like there, and then there. We're just trying to pick same distance to there as it is to there. All right, same distance to there as it is to there. And just kind of make your parabola the best you can right there. So we're just kind of creating a parabola, knowing that the points on the parabola have to be the same distance to the focus as they are to the directrix. Just practice. This whole page was just practiced on the definition of a parabola. Every point in the parabola is the same distance to the focus as it is to the directrix. You're going to hear me say that a lot. Now, we recall vertex form, y equals a times x minus h squared plus k. We did that in lesson 29. If you didn't watch that video, go back and watch that now before you continue. We talked about the distance p. P is a distance from the vertex to the focus and from the vertex to the directrix. That equal distance right on the axis of symmetry, that's the label, that's the p value. Here are your formulas for p. P equals 1 over 4a and a equals 1 over 4p. That's not going to make any sense to you right now until we get started. But a is this value a in the equation of a parabola. So that stretch factor, that vertical stretch factor is a, and the p value has a relationship with that vertical stretch factor. The p is 4 times the a, okay? So that's kind of how, that's the relationship. Determine the vertex, the focus, and the directrix of the parabola created by this equation. So the vertex, well, we already should know that from lesson 29. The vertex is HK. The vertex is HK in vertex form, which we're already in vertex form. So you take the opposite value of H, and it's just going to be 2. And then K is exactly what you see, 4. So the vertex is 2, 4. How do we find the focus? All right, well, let's see. If we know the A value, A is 8. Not A is 8. A is 1/8. A is 1/8. From the A value, I can get the P value. All right, so P, because P, using my formula right here, is 1/4 times A. P is 1/4 times A. And A is 1/8. So P, my P value that I need to find the focus and directrix, my P value is 1/4 times A. A is 1/8. 4 times 1/8. 4 times 1/8 is a half. So it's 1 divided by a half. And so therefore, 1 divided by half is 2. So my P value is going to be 2 in this case. 1 divided by a half. If P is 2, and if you didn't know 1 divided by a half is 2, you could just put in your calculator or keep switch flip because this is division. We'll talk more about that in class tomorrow. You'll see that. But 1/1/2 is 2. So my P value, P is 1. My P value is 2. A is 1/8. P is 2. How do I get my focus now? Well, let's draw a picture. If I have my axis of, I have a parabola, some parabola. I know it opens up. Okay, I have a focus and I have a directrix. I know my vertex is the point 2, 4. And I know my P value is 2. So I know I got to go up 2 and I got to go down 2. So from that 2, 4, I go up 2 and that's my focus, and I go down 2 and that's my directrix line. The focus is going to be right here. It's up 2 units from the vertex 2, 4. If you go up 2 units, what are you doing? You're adding 2 to the y, so it's going to be 2, 6. My focus is going to be 2, 6. My directrix, you go down 2, and then my line is right here, parallel. Directrix is always going to be y equals, so it's y equals. And what does y equal right there? Well, instead of going up 2, I go down 2. So if this is 6 and this is 4, this is now 2. Y equals 2. Y equals 2 would be my directrix. All right, I'm going fast, but I don't want to kill you with this at night. I know you're going to need to practice this to really get it. Do another example. It's going to work exactly the same, except it's upside down parabola now. It's an upside down parabola because it's a negative. My focus is here, and my directrix is going to be up here now. Okay, vertex is going to be -3, -1. Again, just from lesson 29, opposite sign of that, and then the same sign here. The focus, well, we need A. A is 1/4P. I'm sorry. P is 1/4A. Got to know that formula. A is -1/4, so 1 over, and the negative doesn't really matter, so it's 1/4. It's really the absolute value. 1/1/4, and 4 times a fourth is 1, so it's really just 1. So in this case, P is 1. Once you have your P value, you go to your diagram, and my vertex is right there at -3, -1 on a graph. We don't need a grid necessarily to do that. So if I'm at -3, -1, and I go, my focus is going to be down 1. My focus is going to be down a point now because the parabola goes down. So if I go down 1 from -1, I go to 0. This is going to be -3, 0. And my directrix actually goes, oh, I'm sorry, no, that's wrong. Oh, I'm sorry. You go down 1 from -1, it's -2. -3, -2. So my focus is going to be -3, -2. From -1, you're going down 1 unit, that's -2. My directrix, I'm going up 1. Right here, if I go up 1 from the -1, I'm at 0. So y equals 0 would be my directrix line in this case. determine the equation of a parabola if I know the focus and I know the directrix. Okay, so if I know the focus is 0, 2, and I know the directrix is the x-axis, this is the x-axis here, I know that this is the point, my vertex is going to be the point 0, 1, because that's right in between the focus and the directrix is the point 0, 1. 0, 1. All right, so now what's my p-value? Well, my p-value is obviously 1, because it's up 1, down 1, so my p-value is 1. My a value is 1 over 4p. Just like p is 1 over 4a, just like distance equals rate times time, time equals distance over rate, rate equals distance over time, same idea. It's that inverse variation relationship. So a is going to be 1 over 4p. I know p is 1, so a is going to be 1 over 4. A is going to be 1/4. And now that I have my a value, all right, I can write the equation of my parabola. Y equals a is 1/4, and then x minus h is 0, x minus 0 squared, plus k is 1. So y equals 1/4 x squared plus 1. There's the equation of my parabola. Y equals 1/4 x squared plus 1. If the focus is 0, 2 and the directrix is the x-axis, it's y equals 1/4 x squared plus 1. All right, and couple more examples here and we're going to be done. Determine the equation of parabola, focus -4, 3, -3, and directrix y equals -1. So my vertex I need, now I'm going to draw a picture here. My focus is below my directrix. So if I just draw a little graph here, my directrix is y equals -1. And because my focus is below that, -4, -3, this is my focus, my vertex needs to be right there. Just kind of draw a sketch of what we're looking at here. If my focus is -4, -3, my vertex is up 1 unit because this is -3 and this is -1, so the vertex must occur at -2 right in the middle there. So -4, -2. -4, -2 will be my vertex. My p is 1 again. And just from the last example, when p was 1, a was 1/4. That's never going to change. So a is 1/4. I already know that. So what's the equation of my parabola? Y equals negative, because it's upside down, 1/4 x plus 4 squared, and then minus 2. So 1/4 is my a, and it's negative because it's upside down. -4 in the h gives me plus 4 when I do x plus 4 there. And then minus 2, my k value stays the same. So there's the equation of my parabola. Example 5, given the equation of parabola in standard form, rewrite it in vertex form. Recall from lesson 29, we need to do that by completing the square. So I'm going to move that 4 over. Y minus 4 equals x squared minus 6x. Add 9, that's half of 6 squared. Add 9 to both sides. Y plus 5 equals x minus 3 squared. And then subtract that 5 over. Y equals x minus 3 squared minus 5. That's from lesson 29. So there's my vertex form. Determine the vertex, focus, and directrix. That's pretty easy. Vertex would be 3, -5. Got to change that sign there. The focus, okay, so let's see. We have focus is going to be, well, we need our p-value, so let's do p is 1 over 4a. Oops. 1 over 4a, okay? And a is 1, so p is 1/4. So in this case, my p is 1/4. That means I'm going up and down 1. Now, you know what opens up? We know our vertex is at 3, -5. 1, 2, 3, -5. I know it opens up. So it does something like that. So my focus and my directrix, now the p is only 1/4. So I'm only going up 1/4 and down 1/4. So my focus is going to be up 1/4 from -5. That's going to be -4 3/4. -4.75. You're only going up 1/4. So that focus is going to be 3, -4 3/4. My directrix, I'm going down, so it's going to be y equals -5 1/4. Y equals -5 1/4, or y equals -5.25. That would be the directrix, because you have to go down 1/4. So this can happen. You can get not so nice directrix and focuses. And I think the last one, the last example 6, we're going to save for class, because that's using the distance formula to just check our work, basically. So pretty much with the lessons done on video, it's just there's like a check that example 6 pretty much is, and we're going to do that together tomorrow, right before that warm-up. We'll see you then.